A square conducting loop is placed in the neighborhood of a coplanar long straight wire carrying current I. So here it is a long wire carrying current I, and using right hand palm rule we can see that because of this current, magnetic field on this side is going to be inward. So magnetic field because of the wire is inward at the site of this rectangular coplanar loop. Okay, and one more thing, if we talk about the magnetic field due to some circular loop like this, circular loop or any kind of loop, not just circular, rectangular, square or any arbitrary shape. So if there is a loop and say current flowing through this loop is in this sense, which is anti-clockwise, in that case magnetic field due to this wire will be outward, and when current flowing through the wire is clockwise, in that case magnetic field produced will be inward, and you can see this with the help of what? Right hand screw rule. Okay, so you can easily see the direction of the field produced due to the closed loop of wire. So here you can see that we have to select a square conducting loop is placed in the neighborhood of a coplanar wire, long straight wire carrying a current I. So if di by dt is less than 0, means current in this wire is decreasing. Current in the wire is decreasing, that means the magnetic field B at the side of this rectangular loop will be decreasing. If the current is decreasing, then B is decreasing. And according to Lenz law, the induced EMF in this loop will be such that it always opposes the change. Means whatever is the cause of change of flux, because of the decreasing magnetic field, its flux is going to decrease. So it's going to oppose the decrease of the flux. So it will try to increase its flux by increasing the magnetic field B. So it will try to create a field in the same direction as that of this particular wire, so that decreasing field may be controlled. So you can understand that for inward field, the current has to be clockwise. So option A is wrong, because when current is decreasing, then magnetic field is decreasing, then created field because of this wire should be in the same direction of the external field, so that it may oppose the decrease of the field. So same direction means inward, inward means clockwise current, but it is anti-clockwise here, so option is wrong. If di by dt is greater than 0, then current in the loop is clockwise. If di by dt is greater than 0, in that case current in the loop is clockwise. Greater than 0 means magnetic field is increasing. If it is greater than 0 means magnetic field is increasing, so it will try to decrease the increasing magnetic field. So it will create a field in outward direction, so that external inward magnetic field may be opposed. Since current is increasing, so field is increasing, so rectangular coil will apply its field opposite to the external field in order to reduce this, because Lenz law always says that it always opposes the change. So for this kind of field, the current should be anti-clockwise, but here it is written as clockwise. So this option is also not right. C option, if di by dt is greater than 0, current in the loop is anti-clockwise. Since we have discussed this option A, you can see that since this is wrong, it has to be correct. Okay, so we have got the option C as the right option for this question.